In this video, we're going to talk about a modern and powerful CI/CD tool called TeamCity. First, we're going to see some of the cool features and benefits of using TeamCity. We will also see the architecture of how TeamCity actually works. And finally, I will show you how to set up and configure your first continuous integration pipeline in TeamCity in under 15 minutes. Traditionally, when we think about CI/CD tools like Jenkins, we think about a tool that needs a lot of administration and configuration. So administrators have to set up the tool and configure it with a bunch of plugins so that developers can start using it and start creating build pipelines for their projects. In Jenkins specifically, you have a vast ecosystem of plugins, and for any imaginable configuration step in your build pipeline, like deploying to a remote server, for example, using credentials, checking out from a Git repository, executing npm commands, etc. So for any of these steps, you have to find a suitable plugin and configure it and use it for your build. Now, the main advantage of TeamCity is that the setup and administration is way easier. So if you want to set up a webhook for automatic build triggering, for example, you don't need a plugin for that. You get that out of the box. Or you want to use Gradle with a specific version for your project, no need to configure it, you can simply use it in your project. Or you want to connect to a Docker registry or Slack account, simply add a connection to your project and you can use it in your build configuration. And most of the common configuration steps that I mentioned are already built in. So you don't need any external plugins or third-party add-ons to use them. Now, if you don't want to set up and take care of the TeamCity installation yourself, you can also use the managed solution TeamCity Cloud to create and run your builds, which of course makes getting started with TeamCity even easier. Now, as I mentioned, creating and configuring builds is very easy using TeamCity UI. But in complex projects with lots of logic and lots of steps, you probably don't want to be configuring everything in the UI. Plus, you may want to easily replicate your build configurations. So instead, you want to automate and script that whole process, which means all your build configuration is in Git Repository, so you get version control and history of the changes in your configuration. So you can maintain your build configurations much easier and make them reusable. And you can actually script the builds in TeamCity with Kotlin, which is an open source programming language. Now, compared to YAML format, since Kotlin is a full-featured programming language, you can write more powerful logic and use all the tools and libraries that it provides. And also, it makes it easy for developers themselves to script their CI/CD pipeline configurations. Now, if moving to configuration as code completely is not an option, you can do a hybrid in TeamCity, meaning make changes to your build configurations in the UI and then commit those changes as code to your code repository. So this way you will still have your build configuration as code. Another cool feature of TeamCity is that you can create build chains from your builds by defining dependencies between them. That means you can configure which builds depend on which ones in a chain. So whenever you run a build, TeamCity will check all of its dependent builds and run them first in a correct order. And you can also easily pass the artifacts or other outputs from one build to another. But in addition to running builds in sequence, you can also run them in parallel. An example use case for this would be if you want to run the same tests on different platforms or environments, like on different operating systems or different cloud platforms, etc., before building and deploying the application and releasing it. And one more great feature I want to mention is that you can run what's called personal builds directly from your code editor. Personal builds are like developers' own builds which only they can access. So this is a very convenient way to trigger builds on a remote TeamCity server from your local development environment. This can be really useful if you want to test your changes before committing your code. Personal builds are available for all major IDEs like Eclipse, IntelliJ, and Visual Studio. So if you have TeamCity plugins for these IDEs, you as a developer can also see build status, configuration, and all this information in your IDE without leaving your local development environment. Now let's see how TeamCity works. It has a very clean architecture. You have a central management component called TeamCity Server, where you can configure your builds and see your build information, all in a nice UI. Now, once you configure the builds, they need to run somewhere, right? For that, TeamCity has build agents, and you can add and connect any number of build agents to your server. These agents can be installed anywhere, on an EC2 server, on your own on-premise servers, it could be a Docker container, etc. And each agent can have different tools installed on them. And for each build, TeamCity will automatically detect what build agent can execute that build based on the steps configured in that build. For example, if your build is using npm command to run JavaScript tests, for example, you will need a build agent with npm installed on it to be able to run that build. If your build creates Docker images from your application and pushes them to a Docker registry, obviously Docker will be needed to run these steps, right? So TeamCity will automatically detect a build agent with Docker installed on it and execute the build on that build agent. And in the free professional version of TeamCity, you can connect up to 3 build agents to your TeamCity server. Now let's see how TeamCity works in action. First, we will install TeamCity server and then configure a continuous integration pipeline for a simple Java Gradle project that builds a Docker image and pushes it to a private Docker Hub registry. And once we have configured that, we will connect build agents to the TeamCity server so that we can run our build. So let's do it. So the first step is to install and set up a TeamCity server. So the main component basically where we can create and configure our builds. And on the official website of TeamCity, you can see different installers for different operating systems. Plus, we have an option to install TeamCity server as a Docker container with this command right here. And as a managed TeamCity alternative, you can use TeamCity Cloud. So for those who want to avoid setting up and configuring TeamCity server and agents themselves, you can use TeamCity Cloud instead to get started faster and more easily. However, in this video, I'm going to show you how to set up TeamCity using Docker. So basically, we have this TeamCity server image from JetBrains, which has most of the stuff already pre-configured inside. So we're just going to start this with simple docker run command, and we're going to have TeamCity server available. And I'm going to do this on a remote server on DigitalOcean's Droplet server, which I just created. And the only thing I have done on this server is basically just do apt upgrade and install Docker, right? Other than that, it's completely fresh new server. So let's execute the docker run command. And let's also see all the options that we have to add to this command. So I'm going to do a new line here. And we have a couple of volumes that we want to configure for TeamCity, because all the configuration that we do, the builds that we create, etc., they need to be stored somewhere, right? And we want them to be persistent. So we're configuring volumes for that. So I'm going to call this TeamCity data. These are named volumes, and these are going to be mounted into the data TeamCity server data directory. Then we have another volume for the TeamCity logs. So let's call that TeamCity logs. So note that these are basically just named volumes in Docker. You can call that whatever you want. Docker will create these physical location on the host automatically, and these are the paths inside the TeamCity server container. So these two volumes are needed, and then we have the usual port basically that we bind on the host. Here you see the TeamCity server is running on port 8111, and that's the port that we take for host binding. And finally, we have the image name, right? So let's do a new line, and we want to run all of that in background, so detached mode, and the name of the image. And I'm going to execute this, and TeamCity server image will be downloaded, the latest image, and in a couple of seconds, basically, we will have the TeamCity server available. Awesome. So if we do docker ps, we see TeamCity is running and available on this port. And I have already allowed the firewall rule for that port on my droplet. That means that using the public IP address and port 8111, we can now access TeamCity. And on the initialization setup step, you basically have an option to choose which database you want to use to persist the data. For a test version, you have this internal database that you can basically very easily get started with. So you don't need an external database for it. So we're going to choose that and proceed. So now that TeamCity is initialized and ready, we can create our first project and connect it to a Git repository. So on create project, and for this project, I'm going to use my Java Gradle application, which has a Docker file. So we're going to build Docker image and push that image to a private Docker registry. You can find the repository link and all the other relevant links in the description of the video. So I'm going to copy the URL of my project. And here we're going to need credentials of Git repository itself. And proceed. So the connection to repository was successful. Here you can set the project name, default branch, and some other configuration options. We're going to leave all of that at defaults and proceed. And here, as you see, TeamCity detected automatically from the project which build steps we would need to execute, right? Since it's a Gradle project, we have the Gradle build task and we have Docker tasks. But to show you how you can actually configure that manually, I'm just going to click here. Our build configuration is going to be simple. We're going to do Gradle build first because we want to create a jar file from our Java application. I'm going to scroll down here to Gradle. And once selected, we have options for that specific runner type, right? So for Gradle, we have all these options. So we can call the step build application or build jar. And here we have the Gradle tasks that we want to execute. Let's say we want to do clean with Gradle first, and then we do build. So these two tasks will be executed. You can just separate them like this. We have a Gradle wrapper in the project, so we can choose this, and everything else can stay the same. And let's do save. And this is how build step list basically looks like. So we have build application, and the next step will be to build Docker image, right? So I'm going to choose Docker runner. And as you see for Docker, you have Docker specific configuration. Let's call this build image. The build is selected as default. We're going to use Docker file as a source. And to select the path to file, we can actually click on this icon here, which will show us the files in our Git repository, right? So this is the same structure as we have here. And from here, we can basically select the path. Docker file here is in root, so I'm just going to click on it, and that's the path to file. And right here, we need to specify the name and the tag that Docker build will basically use. And as you probably already know from my other Docker videos, when we want to push a Docker image to a Docker repository, we need to tag that image using the repository name, right? So in my case, I'm gonna push that Docker image into my private Docker Hub repository, and that's the name of the repository. So I'm going to copy that. And then we have the tag option. And let's say we want to tag our application as my app and some version, let's say 9.0. And it's also common practice to append a build number as part of the tag name. And this build number, build count, etc. values are usually available in a CI/CD tool using build parameters. And in the build steps here, you have this convenient way of looking up all the build parameters that TeamCity provides you with. So if you want to append build number here, I'm just going to click on it, and this will basically append a build number at the end of the tag. We can also build multiple images with different tags in this step by just providing them on the next line. So in addition to this specific version, we're also gonna build an image with just latest tag. So every last image that we build is going to be latest as well. And we can define that like this. And let's save this step as well. So we have build application jar file, build image, and now we can create push image step with Docker runner. We're gonna choose push here, and these are the two images that we are pushing. And if you notice, in every build step, you have this advanced option, which basically lets you choose a conditional for when the build step can run, right? So you can configure whether this build step should run only if the previous ones were successful, etc. And we're going to save this step as well. And this will give us a build in the project that we created with these 3 steps. Now, Docker repository, as I told you, is a private one, right? So how does TeamCity know how to connect to the Docker repository to basically push the images into it, right? Usually we need to do something like Docker login to authenticate with the private Docker registry. For this type of connections, basically from TeamCity to other platforms or other servers, we have connection configuration on our project. So if I go to my Java app project, on the project settings, we have connections option here. So all of the connections to these external systems that you need in your project, you can basically configure all of them here. So in our case, we're going to choose Docker registry, which is Docker Hub. This is the default registry address, which is Docker Hub. This is what we're using. And here we are going to need the credentials. That's my username and the password. And we can test the connection. As you see, connection was successful, so I'm gonna save it. And now once that's configured in the project, we can use it in all the builds of this project. For that, going back to the build settings in build features, we're gonna configure something called Docker support and add registry connection. And we're just gonna choose Docker Hub here, save, and we're good to go. And as you see here, this will basically log into Docker registry before the build gets executed, right? Which is exactly what we need, because we need the authentication before Docker push command gets executed. And with this configuration, our build is configured and ready to run. But to run a build, we need an agent. So this is TeamCity server, and we need agents to actually execute the builds. And right now we have 0 agents because we haven't connected any to our server. So as the next step, we're gonna connect an agent to our TeamCity server. So how can you deploy and set up TeamCity agents? You have the same options here as for the TeamCity server. You can install it directly on your operating system, run as a Docker container, or again, if you want to avoid manually setting up and configuring agents, you can use TeamCity Cloud, which will automatically make all the suitable agents available for you. I'm going to use the Docker image here as well for a fast local setup by executing the following Docker command. Again, configuring the volume for configuration data and specifying where the agent should connect to the TeamCity server using server URL environment variable. So let's run this. And now if we go back to our TeamCity server UI and agents, we still have 0 agents, but we have 1 agent which is unauthorized. So this is the agent that we just deployed, but not authorized. Just click on the authorize, and now we have 1 connected agent. So that's basically how you can connect agents to a server as a Docker container. Now, as I already mentioned, TeamCity will automatically detect which agents are actually able to run which builds based on what's configured on them, right? Which tools are installed on them. So let's actually see how that detection looks like. So I'm going to go to the build, and here we have this compatible agents tab, right? And it says compatible agents is 0 or none, and we have incompatible agent. So 1 agent deployed, which doesn't meet the criteria for running this build. And TeamCity server actually detects that by checking whether docker.server.version is available on that agent. And it is not, because we deployed it as a Docker container, but there is no Docker available inside it, right? So basically it's not suitable to run our pipeline because we need to run Docker commands for our build. So now let's run and connect an agent which is going to be compatible to run our build. And to do that, we're going to run another TeamCity agent container, but we're going to mount the Docker from the host inside the container using the following Docker command. You can find the detailed explanation of all the command options you see here and how Docker is mounted from the host in the video description, along with all the relevant links. So check out the description for that. And let's run it. So our second TeamCity agent is running. And now if we go back to our TeamCity UI, you see that we have another unauthorized agent. So let's authorize that as well. And this may need some time, but if I refresh this now, you see that we have 1 compatible agent and we have 1 that doesn't meet the requirement. So that means that now we can actually execute our build. And to do that, we have this run command here with some additional options. So for example, you can pass in some parameters if you want. You can select the agent. So for example, if you have multiple compatible agents, you can select which one you want to run this on, etc. We're just going to run the build. So here we see the overview of the build, the status, branch, etc. And here you can also see the logs of the build. So we see that all these steps got executed, and we should be able to see our latest tag as well as tag with the specified version and with build number in the Docker Hub private repository. And here you also have a summary of the images that were pushed to the repository. Now, of course, in your projects, you want to configure automatic triggering of builds when you push the changes or a pull request is made, and also configure which branches should be built, etc. And you can configure all of that pretty easily with the triggers in the build configuration, where you have all these options available for different use cases and for different trigger types. And finally, as I mentioned, with the best practice and the new trend of having configuration as code instead of doing everything in the UI, you also have an option to see all of this and save this configuration as code. And in the build configuration, we have this view DSL button. And if I click inside, you get this auto-generated build configuration code, which basically describes exactly what we did in the UI with the build steps and triggers, etc., written in Kotlin programming language. And optionally, you could also work with this file which you can use as a basis to basically expand on your configuration and configure the rest of the stuff as code. Now, this is obviously a subset of the things you can do in TeamCity because you have tons of other powerful features in addition, but this is to demonstrate how easy it is to get started with TeamCity, to set it up, to connect the agents, and basically just configure a simple pipeline for your project. Now, I hope you learned a lot in this video. Let me know in the comments what you think about TeamCity and what's your experience with other CI/CD tools. And with that, thank you for watching and see you in the next video.